So there are several different methods for factoring quadratic expressions. In this particular course, we're going to just look at the trial and error method. Now, some of you may know of other methods for factoring that are a little bit more methodical than the one that we're going to look at here. And if you still remember how to use those methods, they're perfectly fine to use. In this particular course, we're going to look at a lot of things with data, and when we look at the quadratic expressions we get through data, they don't factor, and so we're not going to be spending a lot of time in this course on factoring. So in this case, working backwards is like a trial and error puzzle to get the correct factors. So example 2 tells us to factor the following using the patterns for the coefficient of the x squared term and the constant term, and then just using trial and error, or guess and check, to try to get the rest of the problem correct. So if we start with the first term here, an x squared, and we know this last term we have to get is a positive 12. Okay, so here's our starting with the first and last terms. Okay, well, the only way that we can get an x is to take x times x. Okay, so we know each of our factors initially here starts, so again, to get this in factored form, to factor, okay, so again, there's an important verb that means at the end of the day we need something that looks like this, if we start with a quadratic. And now, working backwards, so how do we get a positive 12? So let's try negative 6 times negative 2. Okay, so negative times a negative is a positive. This is going to give me negative 6x and negative 2x. So now if we combine like terms, we're going to get an x squared minus 8x plus 12. Okay, so this one matches, and the plus 12 match, because we forced them to be that way. But now we're just using kind of trial and error to see if we're going to get our x term with the right coefficient. And we're really close, but not right. Okay, so this doesn't work. Okay, so this is not right. So let's try another one. So first term needs to be x squared, and the last term needs to be a positive 12. Okay. So how else can we get a product of 12? So let's try positive 4 and positive 3. Okay. Well, that's going to give us a positive 4x and a positive 3x. And when we combine like terms, get some of this out of the way down here. When we combine like terms, we're going to get x squared plus 7x plus 12. Okay. So now if we compare that, here's our x squared, but now this has a subtract 7x and this has an add 7x. Okay. So not quite, just off in sign. Okay, so let's try, instead of a positive 4 and a positive 3, a negative times a negative will also give us a positive here. So x times x is x squared, negative 4 times x, negative 4x, negative 3 times x, negative 3x. And now when we collect like terms, we're going to get x squared minus 7x plus 12, okay, which is exactly what we want to have happen. Okay, so this expression factors as x minus 4 times the quantity x minus 3. Alright. So now 5x squared minus 11x plus 2. Again, if we take a look at the first term, the only way we can multiply to 5 is 5 times 1. So we're going to take 5x times x. That'll give us our 5x squared. Our last term here, our constant, we're going to get plus 2. Okay, so let's try so we're going to get some negatives here. So let's try negative 1 times negative 2. Okay. So negative 1 times negative 2 gives us a positive 2. Negative 1 times x, so minus 1x. And negative 2 times a positive 5, we're going to get negative 10x here. Okay. So now when we collect like terms, we're going to get 5x squared minus 10 minus 1 minus 11x plus 2. And so here our guessing, we happen to guess what worked right the very first time. So 5x squared minus 11x plus 2 factors as 5x minus 1 times x minus 2. Okay. And again, in upcoming we're going to learn why this is a preferred form for this expression over this one when we're trying to solve these types of equations. Alright, so now 2x squared minus 5x minus 12. Okay, so 2x squared we can get with a 2x and an x. And 12 is not very friendly because there's lots of pairs of numbers that multiply to be 12. So let's try a negative 6 times a positive 2. So we're going to get negative 6x, positive 4x, which when we add, we're going to get negative 2x minus 12. So again, our first and last terms match, but our x term does not have the right coefficient. So how about 2x and x? That still gives us our 2x squared. We try a positive 3 and a negative 4. That will give us a negative 12. Okay, so again, we're forcing the first and last terms to work, and then again, we're trying to see if we can get our x term to have the right coefficient. So negative 4 times 2x, we get negative 8x, and plus 3 times x, we get a positive 3x. Okay. So we get 2x squared minus 5x minus 12, which does match. Okay, all three terms are correct. So 2x squared minus 5x minus 12 factors as 2x plus 3 times the quantity x minus 4. Okay, so one more. So again, 3x squared minus x minus 2. Okay, so we've got our x squared term, our x term, our constant term. So again, our first term is 3x squared, and our last term is negative 2. Well, again, the only way we can get a 3 is 3 times 1. So 3x times x will give us a 3x squared. And here we need negative 2. So let's try negative 2 times a positive 1. Okay. So 3x times 1 gives us a positive 3x. And a negative 2 times x gives us a negative 2x. So again, collecting like terms, we get 3x squared plus 1x minus 2. Here we have a plus 1, and here we have minus 1. Okay, so not quite. So let's try a 3x plus 2 and an x minus 1. We get 3x squared and our negative 2 for first and last terms. But now we're going to get a positive 2 times x, so plus 2x, and a negative 1 times 3x, so negative 3x. So again, when we combine like terms, negative 3x and a positive 2x, subtract x and subtract 2. And again, this matches the expression we started with. Okay, so 3x squared minus x minus 2 factors as the quantity 3x plus 2 times the quantity x minus 1.